the test in front of me. Sorry, my computer's been really slow.
No, you're good.
I think my computer's ready for like the semester to be over.
Yes, I think everyone is.
Yeah. Okay.
What? I'm trying to think about it.
Okay, sorry. So what I was doing to find the interval for it is I took I rearranged it as 2 raised to the 1/2 power. And then I just added 1 to the exponent, which would give me 3/2.
I already know what your problem is. So
Okay.
what you're doing is you're using power rule, right?
Mm-hmm.
But there's no x in here. There's no x. It's just a constant.
Goodness. You're right. Why did I not notice that? Okay.
Yeah, no. It's because the x is under our roots a lot of times.
Yeah.
So
Yeah. Oh, that's hilarious. Okay.
yeah, so the antiderivative would literally just be root 2.
2x.
Or yeah.
Oh, yeah, theta.
It's q, but yeah. And then just plug in the roots and simplify.
Oh, okay. All right, that made sense then.
Yeah.
Yeah, that's
Stop.
fine. Okay.
That.
And then the last one was 12.8. I don't understand why he got rid of the e in the problem.
Oh, whenever he evaluated that. So you understand the antiderivative is the natural log, right?
Yes.
So the opposite of the natural log is
Oh.
the ln of b is equal to 1, which is one of our properties.
Mm-hmm. Gotcha.
So, like, if you have natural log of e,
Mm-hmm.
then that's just 1, and it's just that 1 exponent. But if it was natural log of, like, e to the x, it should just be x.
Okay, so that's in natural log form, because I thought it was just like in fraction form. But if it's in log, that makes sense. Yeah, it is in log. Okay. Okay, that makes sense. All right, that's it, Sarah. Thank you so much for explaining it.
All right, no problem. I'm glad it helped. And I don't know if you need more practice with the Riemann sums, but we're just doing an additional. I don't know why I went over there. An additional problem from it.
Okay, cool. I just need to practice a little bit more. I kind of got the basics down. Just need to do them a little bit more.
Yes. All right. Well, thanks. Oh, did I give you the attendance link? I don't think I did.
No, we do.
Okay, there it is. And then, Stephanie, how are you doing? You're confused? What are you confused about? Or what? Well, tell me what you got to, or where you've gotten to so far.
I was looking at it, and I was like, I'm trying I didn't understand like that part, like where we're supposed to like put it, like where we at. I was confused. I'm like looking at the problems. Yeah.
So is that is 2x plus 5. Does that make sense?
I'm sorry.
Yeah.
My Wi-Fi is going off and on. I'm gonna reconnect again. Is that fine?
We'll be fine.
Okay. Sorry, Sarah. My Wi-Fi went off.
You're totally fine.
Okay.
So whenever we get to this point where we've plugged in our A and our B and we've simplified this right side Riemann sum, we see that we still have this f of what's in here, right? And all that means is that we see we have our function f of x is equal to 2x squared minus 2x plus 5.
Mm-hmm.
And I would recommend you do this, like once you get to this point and you've simplified the right side but haven't plugged in the function yet, you write down your function, which is just whatever's on the inside of the integral that you've been given.
Uh-huh.
And then everywhere you see an x, you're going to replace with this
Okay.
1 plus 2k.
Oh, okay.
Yeah, does that make sense?
Yeah, because I was putting that the E symbol in it too, and I was like wait, this is so weird.
Yeah,
Yeah.
you're totally fine. Yeah.
Okay.
Yeah, so all we're doing is we're just going to plug in that 1 plus 2k divided by n, where everywhere where we see an x. So we're going to get 2 times 1 plus 2k divided by n squared minus 2 times 1 plus 2k divided by n plus 5. And then do you want to go ahead and simplify this outside of the sum, or do you want to go ahead and put it in?
Can we simplify it? Would that be better? Or
Yeah, I mean, it's whatever your preference is. I would probably simplify first,
Okay.
since we've already written it out, because whatever this side is equal to, we're just going to end up plugging in right up there.
okay.
All right, so working downwards and simplifying, we're going to have to multiply this by itself and then multiply the 2 across there. So 1 times 1 is just 1, 2k divided by n times 1 is 2k divided by n. We do the same thing, 2k divided by n times 1 is still 2k divided by n. And then 2k divided by n times itself is going to be 4k squared divided by n squared. And then for our next term, we're distributing that 2 to both, right? This is actually the part where I lost points on when I took this exam.
Oh.
I've only distributed the 2 to, I think, this term, and I didn't distribute it to the other term.
Oh.
So just be careful about that, because that's kind of why we're so hard on parentheses, because like it's really easy to not do stuff like that even with parentheses. So
Yeah.
so we're gonna get a -2, and then also don't forget about the negative sign too.
Okay.
So it's gonna be -2, and -2 times 2k is gonna be -4k divided by n plus 5. And then we're just going to distribute that 2 everywhere. And then we can also combine this -2 and that +5.
Oh, yeah.
So we're going to get 2 plus, and then we can also combine those 2 after. I'll do it after we distribute the 2. So we have 4k divided by n plus 4k divided by n. 4k squared divided by n squared. 5 minus 2 is +3 minus 4k divided by n.
So for the we don't like distribute the 2 with the 4k squared over n squared?
Oh, no, we do. I
do?
just
Okay.
didn't do that for some reason.
Okay.
Thank you. This is a good catch, yeah. We
Yeah.
definitely do distribute it. That was just my fault.
It's okay.
And the funny thing is I know that would have changed our answer, I think. I think that would have changed our answer.
Yeah.
It might have. It might have not. That's like the scary part about this, is like you can make a mistake like that.
Mm-hmm.
Like I think when distributing this, like my final answer was still correct. So I must have not distributed to like one term that doesn't particularly matter, and it's just, I don't know, but
Yeah.
you'll still get points off for not having like the work being correct, you know.
Uh-huh.
All right, now we just got to combine like terms. So now we just have the 2 and the 3 to add together, so that's going to be a positive 5. We can add, let me just highlight those, and then we have our 4k divided by n, 4k divided by n, minus a 4k divided by n. So that's just going to leave us with 1 4k divided by n. And then we have our plus 8k squared divided by n squared.
Wait, can you explain again with the 4K?
Yeah, so we have 2 positive terms and then 1 negative term of the exact same. So this term and this term are going to cancel out since one's positive, one's negative.
Yeah.
And then it just leaves us with 1
With
4k divided by n.
Okay.
If you want to, you could have added these two together to get 8k divided by n and then subtract 4k divided by n.
Mm-hmm.
Does that make sense?
Yeah, because I thought we were distributing, that's why.
You know, we just distributed. I just still wrap those parentheses right here just to show that, just show that's this whole thing.
Okay.
Is this whole thing. Does that make sense? Like,
Yeah.
that's just more for, so it's easier for you to follow.
Yeah, that makes sense.
Alright, but now we're at a point where we've simplified completely, and we want to plug this thing where this thing is. Because this is exactly what this is. Does that make sense?
Yeah, like, we're plugging it back into, like, is it the E, because we were learning it from the exam 11 kind of thing?
What do you, are you saying E? I just want to make sure.
It was like N and the, I think, in our memorization. I'm just gonna check it just in case.
Let me look at the memorization. Give me 1 second to pull it up.
It was like, the constant equals like the N, and the K equals like the N, and parentheses N plus 1 over 2. Is that like what we're kind of doing here?
Oh, like from exam 11 where we have like the n times n plus 1 over 2 is equal to the summation of k.
Yeah.
Yeah, we are going to use that.
Okay.
Was that your question?
Yeah, because it kind of looked like that circle in blue. It looks like that, that's why.
Yeah, so what we're doing is once we, so it's kind of similar to what we did on the last exam. We just have more steps.
Okay.
And then we also just don't plug in that n value, because on the last exam we were given a value n. But this exam it's just staying n. So whenever we plug in those formulas, then we're just going to keep it as n. Does that make sense?
Yeah.
Okay. So plugging that back in. 1 to 3, 2x squared minus 2x plus 5. You're going to have the limit as n goes to infinity of 2 divided by n, and the summation k equals 1 to n, and then we're substituting that 5 plus 4k divided by n plus 8k squared divided by n squared.
Do we also put like the F before those parentheses, or?
No.
Okay.
So this is, if you notice, this f of 1 plus 2k over n is exactly this f plus 1k plus 2k divided by n.
Okay.
Like, all we're doing is we're plugging in it. So the f just signifies that this is some function and this is the variable of the function. It doesn't matter what's in here.
Oh, okay.
Does that make sense?
Yeah.
And so our function that we were given, which we can call f of x, because x is our variable, is our 2x squared minus 2x plus 5. Now, with this formula that's inside the summation, they want us to find the function, our same function that we were just given, of this 1 plus 2k over n. So everywhere we see an x, we're going to plug in that 1 plus 2k over n.
Okay.
So that's how we end up getting. So that's what we're doing from here. Sorry, I know this looks kind of messy, but that's what we're doing from here to here, is we're just substituting that x value for that 1 plus 2k over n, and then simplifying. And since this is the exact same thing, this f of 1 plus 2k over n is what's inside the summation. We want to get rid of that function. We want to know what the function actually is and substitute it in, since they're equal to each other.
Oh, okay. Okay, it's making sense now.
Okay. I can, after the SI session, I can try to write this out on paper more neatly,
Okay.
so it's like flows a little better.
Okay.
But yeah. So everything makes sense up until this point. All we did was substitute that value in for x. We simplified, and then we plugged in what we simplified for into
Okay.
into our summation.
Okay. Yeah, that makes better sense.
Okay. And then from here, I don't know which way you prefer to do it. I guess on the SI session last time, because I didn't want to keep writing this limit,
Mm-hmm.
I set this whole thing equal to s, which just means the sum. Are you okay with me doing that? Does that make sense?
Yeah, that's fine. Are we allowed
Okay.
to do that like on the exam as well, or he doesn't
Yeah.
like it? Okay.
Yeah, that's literally what I did on his exam for this
Oh.
question.
Okay.
Because I know at some point I'm going to drop the limit sign and then forget what I'm doing if I don't do it this way. Does that make sense?
Yeah.
So we're just going to set, or I guess before we do that, we'd probably say the limit of s of n is equal to the limits of 2 divided by n, k equals 1 to n, that's 5 plus 4k divided by n plus 8k squared divided by n squared. And so now we can say that s of n is equal to 2 divided by n times the summation of k equals 1 to n, and then we have 5 plus 4k divided by n plus 8k squared divided by n squared. Because this just looks a lot nicer to work with, in my opinion.
Yeah, it does. It's like more cleaner.
So all we do now is that 2 over n times that summation symbol.
Yes.
We're just going to distribute that to each individual term.
Okay.
Very similar to exam 11, we want our summations to look like those formulas that we memorized, like the summation of 1, summation of k, and the summation of k squared. We're going to distribute that summation and then manipulate it, like pull out the constants in order for us to substitute those formulas.
Okay.
So we're going to get 2n times the summation of 5 plus 2n times the summation of 4k divided by n plus 2n times the summation of 8k squared divided by n squared. So everything that's not 5 times 1 is just 1. So everything that's not one of those things that we learned, right? So our 1, our k, and our k squared, anything that's not those, we're going to factor to the outside of the equation. Or not the equation, the summation.
Okay.
So factoring out that 5, we still have that 2n on the outside, so 5 times 2 is 10, so we end up with 10 divided by n times the summation of 1. So that looks good. That's one of our formulas.
Did you get the 2 from that? Is it the 2n? 2 over
Yes,
n? Okay.
yeah, because it's really important that whenever you do this, you also distribute that 2 divided by n with the
The
summation,
summation. Okay.
because you see it's with each of the summations.
Okay.
Yeah, so whatever that constant is out front in this formula is going to stay with the summation whenever you distribute it. Or if you think you might forget to do that, you can always distribute this 2n into each term and then factor it out whenever you're looking for the formula, if that's something you're worried about.
Okay.
Wrong color. Plus, and then factoring out that 4 divided by n, multiplying it by the 2 over n, we get 8 over n squared times the summation of and then plus, we're going to factor out that 8n squared. So 8 times 2 is 16. N squared times n is n cubed. And we're just left with a k squared on the inside. Now, do you remember the formulas?
I remember it was n for the constant, or just a, and then was it n plus 1 over 2?
Yeah, n times n plus 1 over 2, yeah. And then the last one is, if you notice, they all include that n. I'll rewrite them.
Okay.
But of 1 is just equal to n. So the first one is relatively easy to remember. The second one, summation of k plus 1 to n of k. So we still have that n. We multiply it times n plus 1 over 2. And you can kind of think of it as like, I guess let me write the first one before I talk about the pattern, because there's a pattern to this that makes it a little easier to remember.
Okay.
So if you notice in this first one, it's equal to n, but n is also equal to n divided by 1, right?
Yeah.
So we're adding, if you notice, on each term, if we multiply the second one, right, by 2 on the bottom, we get this 1 times 2. And then this third one, where it sticks on the bottom, is 1 times 2 times 3. So it's kind of like we're adding, I guess, let me make this 1 times 2, so it's a little 1 times 2. So on each increase for the variable a, or the variable k, right, there's no k here, there's 1 k here, there's 2 k there. We multiply by the next integer, right? So 1, and then we have 2 on the bottom because that's the next integer, right?
Yeah.
We multiply by 3 on the bottom because that's the next integer, so we have 1 times 3 times 3. And the n we see is constant. We start with a regular n. We then start with n times n plus 1. And that same thing is on the top, but we're just adding that 2n plus 1 to it. I don't know if that helps. It's not really a super concise way to remember it, but that's kind of the pattern I see when I look at it.
Yeah, I see it too. Like, at first I was like, I don't know how I'm supposed to remember this, but then now I kind of like, oh, you're just adding like that, and then.
Yeah, I
Usually-
think the only hard part to remember might be this 2n plus 1.
Yeah.
But if you see the connection on the bottom, I think the denominator isn't too hard to remember.
Mhm.
And then, really the only thing you have to memorize is, okay, the last one also, the third term that's being multiplied up top is going to be a 2n plus 1. You're just adding a 2n plus 1 and a 3 to this one.
Yeah. Okay.
All right, so plugging in those formulas, because that's what we're doing, is we're just directly substituting in these formulas for each of those. So we're going to get S sub n is equal to, and we keep all those constants on the outside. So we're going to be multiplying by n, and then we have that 8n squared, and we're multiplying by n plus 1 divided by 2, and then plus we have that 16 n cubed, and now we're multiplying by n plus 1, 2n plus 1 divided by 6. All right, so we see these n's are going to cancel out. One of those n's is going to cancel out with that n top, and that 2 is going to cancel out with that 8 to make it 4 up top. And then one of those n's is going to now lead to a 2. It's going to cancel out with that n up top. All right. So now doing those simplifications, we get 10 plus 4 divided by n times 1 plus 1 over, oh no, it's just going to be n plus 1. So 4 times n plus 1 over n. And then on this next one, we have 16 times n plus 1 times 2n plus 1 divided by 6n squared. All right, so at this point, we want to simplify as much as possible. So we're going to distribute that 4 to each of those terms, and then we're going to multiply these two to each other. So we're going to get 4n plus 4 divided by n plus 16, and then n plus 1 times 2n plus 1. That should be, it should be the same thing every time. You're always going to multiply that n plus 1 times 2n plus 1. So it should be 1 plus 3n plus 2n squared over 6n squared. Does that make sense so far?
Yes.
Okay. And then now in this one, we're going to split up the fraction into 4 divided by n plus 4n divided by n plus 4 divided by n. And then we're also going to distribute that 16 to each of those 3 terms. Ten plus 4n divided by n plus 4 divided by n. See that those n's are going to cancel out. And then up top, we're going to have 16 plus 16 times 3 is 30. 30 plus 18 is going to be 48n plus 32n squared. Yep, I think that's right. Over 6n squared. And then we're going to do the same thing that we did in that second fraction, is we're going to break it up into 3. I'm going to break this up into 3 different fractions. So we're going to get 10 plus 4 over n plus 16 over 6n squared plus 48n over 6n squared plus 32n squared over 6n squared. Right, so we can simplify that 16 and that 6 by a factor of 2. The top is going to become 8 and the bottom is going to become 3. And then we can simplify that n, get rid of 1 power of n on the bottom. 48 divided by 6 is I can't tell. I think it's 8.
40?
Yeah, it's 8.
Yeah, it's 8.
Yeah. So those are going to cancel out to get an 8 on the top, and then 6 divided by, or 32 divided by 6 is going to multiply by a factor of 2. That's going to be 16 up top, and then 3 on the bottom, and then those n squares would cancel out. So we're going to get 10 plus 4 is 14, plus 4n. Sorry, I'm also solving this for the first time, so that's kind of why I'm thinking out loud. Plus 8 divided by 3n squared, plus 8 divided by n, plus just 16 over 3. Alright, so we're going to need to add these 14 and 16 over 3, and then add that 4 over n and 8 over n together. So we can rewrite that 14 as multiplied by 3 on the top and bottom. So we should get 42 on the top and 3 on the bottom, plus 16 over 3. So we're going to add those together, and then plus our 4 over n plus 8 over n is going to be 12 over n, and then plus 8 over 3n squared.
So you did, I was confused at the, oh no, okay, I see now. Oh, I see. Am I redoing your comment around? Sorry, Sarah.
Yeah. Oh no, you're good. You're good. This is for you, not for me. So if you have any questions at all, please ask. Okay. Let's see. So we should get 58 over 3 plus 12 over n plus 8 over 3n squared. I think our answer over here was 58, wasn't it? Yeah, it was. So that's a really good thing. It's a really good thing whenever you see that first term, or it doesn't have to necessarily be your first term if you rearranged it a different way.
Okay.
But if one of your terms at the end is that number, because you see when we plug in the limits that these two are going to go to 0.
Yeah.
So if your first term is equal to what you got when you integrated it, you know you at least did something right. You might have messed up something with one of these two terms.
Yeah.
But at least whatever you did didn't affect the actual answer.
Okay.
So it's still good to go and double check just to see in case you made any algebraic errors with those two, because if you did, you wouldn't know until you get the test back and you're like, oh, I made a mistake there.
Yeah.
But so if you have time, it's always good to double check that. But then from here, all we have to do is plug that back into the limit. So we know that this integral, I think it was 2x squared plus, do you remember what the second term was?
It was minus 2x?
Oh, minus 2x, yeah. And it was plus 5,
And
right?
plus 5, yeah.
Alright, so we know that this integral is going to be equal to the limits as n goes to infinity of s of n So we know that this integral is going to be equal to the limits as n goes to infinity of 58 thirds plus 12 over n plus 8 divided by 3n squared. And then we just evaluate that integral at infinity. Since we've already simplified, we don't even have to think about simplifying. That's what I really like about this, is you just focus on the output and you don't worry about it until later.
Yeah.
So we're going to plug in infinity, so we get 58 over 3 plus 12 divided by infinity plus 8 divided by 3 times infinity squared. These two are just going to go to 0. So our final answer, this is integral from 1 to 3 of 2x squared minus 2x plus 5 dx is going to equal to 58 over 3.
Wow. Oh, wow. That was a lot of steps.
Yeah, it is a
Yeah.
lot of steps. We are going to do another one on Thursday.
Okay.
Yeah, I'm just going to extend it 30 minutes later, so it's still going to start at 7, but it'll go to 8:30. I need to send an email out about that.
Okay.
Shall